work at the University of Southern Denmark in the Department of Physics, Chemistry, and Pharmacy in a research center called FLINT, which stands for Fundamental Living Technology. And in this research center, we are kind of embedded into the larger community, maybe called artificial life. What we are trying to do, we're trying to create models of living systems, trying to understand living systems by creating models that have lifelike properties. So I've been involved with an iGEM team here at SDU for the last few years, and there's always been a strong sort of ethical component to the research. For example, one year we actually completely switched research topic from one to another because we felt like whatever we could produce from this, from our research agenda could be something that could be toxic. And so we decided, well, we're not even going to take the risk. We're not even going to make any of these kind of experiments, and we're going to switch to a completely different one that we felt is just sort of benign, a demonstration of synthetic biology that wouldn't have any sort of harmful effects on us or on the environment or on anything else. It's probably a blurry border, but I would have to say that artificial has to do something that we make. So the approach that I specifically take and our colleagues take is we try to create something. So whatever we're creating is by definition, I think, artificial in that sense. So it can resemble natural processes, natural life, if you want to say, in various ways, but it will not resemble it in all ways. There'll always be something that looks man-made about it or something that feels man-made about it. So I would say artificial is something that we are creating. It's more of a modification of existing life. It's similar to, say, plant breeding or animal breeding, where over thousands of generations, humans have changed the genetic makeup of organisms to produce something that's different or specific for a function. And this is similar, I think, to what GMOs are getting at. It's using modern techniques, of course, not just breeding, but again, it's looking for a genetic solution to some sort of problem or some sort of challenge. The ultimate responsibility in the work that we do, if we create something that is alive, which is arguable, by the way, how then do we take precautions? How do we take care of it? There's even an ethical question. If we create life, then are we responsible to take care of it, rather than responsible trying to say contain it and keep it away from living systems? So there are lots of ethical issues in that point. Sometimes you hear this argument that when doing the research that we're doing, that we're playing God. I don't suppose that I know what God is, so therefore I cannot suppose that I'm doing anything related to what God does. But one thing, the way I would answer that is what we are certainly doing is creating something. There are different ways of doing science, and one is just observing the natural world and starting to develop a hypothesis based on observation. Another step is to actually create something new, and then maybe that will give you a certain understanding about the natural world. The whole motivation for doing this kind of work is not necessarily to create something new, but to understand what life is, because it's kind of difficult to understand.
And I'm Corporate Vice President for a unit which we call Biotechnology, which is part of our research organization. And what do we do on an everyday basis? I think you can divide it into three main categories. One category is that we do research and development of new pharmaceutical opportunities. Item two is we produce them. in our own factories. Again, on a global scale, we have factories in many different countries. And then 3, we sell them to the patients so they can benefit. So research and development, production and sales, these are sort of the core elements in what we do on an everyday basis. It was chosen to be able to move away from making insulin from dead animals. Previously, insulin was isolated from the pancreatic glands of dead animals, primary pigs, but also to a certain extent cows. This was a cumbersome and dirty process. By introducing genetically modified organisms, we could transfer the production into Baker's yeast, a very small, easily grown, harmless organism that could produce insulin in large quantities and at very large or very good quality. When we produce proteins that are quite complicated molecules, from the natural environment, proteins are produced by living organisms. You can, through synthetic chemistry, add one amino acid to another and then produce small peptides or small proteins. But the proteins that we work with would be very difficult to produce by other methodology than using genetically modified organisms. It would give a lot of impact and burden on the environment if we were to use synthetic chemistry to make these large amino acid polymers that turns into proteins. So I would say no. If we were banned from using genetically modified organisms to produce the type of proteins we make at Novo Nordisk, then we could not make these pharmaceuticals. So it is actually quite essential we can do it the way we do it today. The prime motivation is to be able to help people that have diseases. I think that is our ethical obligation as a pharmaceutical company, always to think about the patients first. Of course, we have to drive a business that has an income, because without an income we cannot develop new compounds. We also have to have high ethical standards in terms of how we act in the environment, in the social environment, and also in the natural environment. So we have obligations to a lot of stakeholders, but the prime stakeholder would definitely, in my mind, be to make sure that we produce good and better drugs for people that have severe diseases. That is the prime motivation for all of us. So patients come first.